Welcome back. Now let's go back to the theory of gradient descent, and perhaps you already begin to understand what this picture of a map is all about. When we vary the parameters a and b and visualize the objective function, we obtain a landscape with level lines in the top right. When we move around in the landscape, with other words, when we change the parameters, we go up or down the landscape and the objective value changes. Now let us discuss the red arrow in this plot. To understand what this arrow means, we must introduce the gradient. The gradient of the objective function is written in this way. The gradient is a vector. It indicates the direction in which the objective function increases the most at a particular position w. Remember, we want to minimize the objective function. Therefore, we need to move in the opposite direction of the gradient. This direction decreases the objective function the most. This direction is given by -1 times the gradient, or what I call the negative gradient. This is what the red arrow represents, the negative gradient. What is nice about the gradient is that we can calculate it with little cost in terms of time. The computation is very fast. One thing you should realize is that the gradient is only locally valid. To illustrate, have a look at the figure in the top right, where I have now added another point and its gradient. Here, the gradient of the red point is pointing in a different direction than the gradient in the blue point. Now please try to make widget number 3 and 4. In this exercise, you will use gradient information to speed up your optimization. Notice that next to the slider, we indicate the negative gradient. This number tells you how to update your parameter. A positive number means you should increase your parameter. A negative number means you should decrease the parameter. Good luck with the widget. Afterward, we continue with the video.